What's up, Tesla fans and DIY mechanics? Welcome back to the channel. Today, we're diving deep into a fault code that can be a real head-scratcher. P0C3F. If you've seen this pop up on your scanner, you're dealing with a drive motor A torque performance fault. So, what does that actually mean? In simple terms, your car's brain, the ECU, is telling the drive motor to produce a certain amount of torque. But the feedback it's getting says the motor isn't delivering. It's like telling your friend to push a box with a specific force, but they're either pushing too hard or not hard enough. The command and the actual output just don't match. So, where do we start looking for the culprit? This fault code points directly to the heart of your Tesla's power. The drive unit assembly. This is the integrated unit that contains the motor, the inverter, and the gearbox. The problem lies somewhere within this powerful piece of machinery. Don't worry, we're going to break down how to diagnose this. It's a process of elimination, but with the right approach, we can pinpoint the issue without just throwing parts at it. Let's get our hands dirty and figure this out. First things first, let's talk diagnoses. How do we confirm what's going on inside that sealed drive unit? The key is to compare the data. Your diagnostic tool is your best friend here. We need to look at two main data points. First is the torque command from the vehicle's main computer. This is what the car wants the motor to do. Second is the feedback from the drive unit itself. This feedback comes from a combination of the torque sensor and the inverter's own calculations based on current and phase angles. When you put the car under load, even just by driving it gently, you can log these two values. If there's a significant and persistent difference between the commanded torque and the actual reported torque, you've confirmed the fault. The ECU isn't just imagining things. There's a real performance gap. Now that we've confirmed the fault, let's move on to the fix. The P0C3F code usually points to one of two main areas. The first, and simpler one to check, is the wiring. We're talking about the high-voltage phase wiring that runs between the inverter and the motor itself. These are the thick, heavy-duty cables that carry all the power. You'll want to inspect the connections at both ends at the inverter and at the motor housing. Look for any signs of looseness, corrosion, or physical damage. A poor connection on one of the three phases can cause an imbalance, leading to incorrect torque delivery and triggering this fault. It's not the most common cause, but it's absolutely the first thing you should check before you think about replacing expensive components. If the wiring and connections look solid, we have to face the more likely and more serious possibility: a fault within the drive unit itself. This could be a problem with the motor windings, a failing position sensor, or, more commonly, an issue with the inverter board that controls the power flow. The inverter is the brain of the operation, and if its components are failing, it can't accurately control the motor's torque output. Unfortunately, these components are not typically serviced individually. The standard repair procedure, and often the only reliable one, is to replace the entire drive unit assembly. I know, that sounds like a massive job, and it is. It involves dropping the entire rear or front subframe depending on your model. It's a big undertaking, but it's the definitive fix for an internal drive unit failure that's causing the P0C3F code. So, to recap, P0C3F means your motor's torque output doesn't match the command. Start by using a diagnostic tool to compare the commanded torque versus the actual torque feedback to confirm the problem. Then, thoroughly inspect all the high-voltage motor phase wiring for any connection issues. If the wiring is good, the problem is almost certainly internal to the drive unit, which means a replacement is in order. It's a tough fault, but with a logical approach, you can diagnose it correctly. Thanks so much for watching. I hope this guide helps you tackle the P0C3F code with confidence. If you found this video useful, please give it a thumbs up, and don't forget to subscribe for more deep dives into Tesla diagnostics and repair. Drop a comment below if you've ever dealt with this code yourself. See you in the next one.